Hello everyone, I'm Gao from Team 19. Today I'm delighted to present our newly developed system called Logify. We've organized this presentation into 6 main parts. The first part is introduction, followed by project background, software requirement, system design, testing, and conclusion. So before we get started, let me introduce our team first. This is our team, GRP-Team19, whose project name is Logic Diagram Generation Software. This is me, Gao, the leader of the team. This is Yuhang Wu, our technical leader. This is Tongchang Liu, our back-end engineer. This is Ziqi Li, our large language model engineer. This is Shuqi Li, our front-end engineer. This is Jason, our documentation writer. Let's move on to the project background section. We conducted an extensive literature review on natural language processing, large language models, mermaid code, and logic diagrams visualization. From our research, we identified several cutting-edge technologies and existing software tools currently available in the market, such as Microsoft Visual and Lucidchart. However, these existing solutions still haven't fully achieved a direct transition from natural language description to visual diagrams. They all require more level of coding or logical module involvement, making them challenging for non-technical users. That's exactly why we created Logify. Our software helps users effortlessly generate flowcharts directly from natural language input. This significantly simplifies the process, removes technical barriers, and effectiveness meets current market demands. Next section, we will talk about software requirements. This slide shows the 5 main functional requirements of our system. First, text to diagram. Users can type in a detailed description, and the system will ultimately turn it into a logic diagram like a flowchart or a mind map. Next, customization. After the diagram is generated, users can click on any node to check details or edit the content if something doesn't match the original logic. Thirdly, interface options. We offer customizable interface settings like dark mode to suit different user preference. Moreover, user login. For now, we are including user login, user register, and history chat tracking. Last but not least, download capability. Users can download the diagrams to their local device for easy access and sharing. For non-technical requirements, 5 stands for allowing at least 5 users to be online at the same time, and 80 stands for at least 80% accuracy of large language model. Next, let's talk about our system design. Let's very welcome Yuhang Wu, our technical leader, to elaborate this section more.
Now, let's start with our user interface. Here is the user login page. In alignment with the principles of LSEPI, which is legal, societal, ethical, and professional issues, our users are required to acknowledge and agree to the user agreement and privacy policy before accessing the system. Then, for first-time visitors, they'll need to register and create an account before getting started. Here is our system's main interface, inspired by the popular ChatGPT layout. If users want to switch up the background color to something they prefer, they can just click the button in the top right corner. Within the setting menu, users are allowed to experience different large language models and select their target logic diagram type. Plus, logging out is straightforward. On the left side of the page, users can either rename or delete their chat history. Super easy to manage past conversations. Once users import their text and click send, our system immediately kicks into action, efficiently generating a clear and structured logic diagram. And here's an example of the completed diagram, clear and ready for analysis or further editing. Editing diagrams is also user-friendly. Users can click on any diagram node, easily modify the content directly, and then simply save their changes. And when the diagram meets their needs, users are allowed to download their work by clicking the download button. Moving on to the technical side, as you can see in the picture, we use the technologies like HTML, CSS, and JavaScript for the front end, and Python with Flask for the backend. We also use tools like Node.js, PyCharm, and Mermaid CLI during development, making systems both efficient and straightforward. Now, let's dive deeper into how our system uses large language models. This workflow shows two main parts. First, the system processing part, where a user enters text and the large language model analyzes and breaks it down, turning it into Mermaid code, which we then use to create diagrams with Mermaid CLI. Second, we have the large language model training and evaluation process. We split data into training and test sets, train the model, and use prompt engineering to guide its responses. This helps us make sure the output is accurate, reliable, and fits different use cases. Finally, here is a quick summary of the large language models we tested throughout the project. For the former three large language models, they failed for a couple of reasons. After that, we tested mainstream lightweight models like Qianwen 2.5 Coder 7B and GRM-49B, which performed more consistently. Most recently, we tried Gamma 3 4B, one of the newest lightweight models. Through this thorough exploration, we selected the optimal model that ensures our software reliably delivers high-quality logic diagrams. Now, let's get back to Ziqi Li.
So let's move on to testing part. Our testing including unit testing, functional testing, and non-functional testing. This table can show the test results of unit testing and functional testing. For non-functional testing, we mainly check how stable the system was with multiple users and how accurate the model response was. To test concurrency, 6 of us logged in at the same time and used the model. It stayed responsive and stable, meeting the goal of supporting at least 5 users at once. To test model accuracy, we evaluate the model on specific dataset. For flowchart situation, Gamma 4B outperformed the other model with the higher total score of 82, followed by GLM4 9B and Qianwen 2.5 Coder 7B. For class diagram situation, again, Gamma 4B lead with a total score of 78, showing strong relation understanding, while Qianwen 2.5 struggled with only 44. For sequence diagram situation, Gamma 4B remained the best performance with 80 points, especially standing out in relation score compared to the other two models. This is the final comparison of how the three models perform across the three diagram types. Overall, Gamma came out on top and best meets our system functional needs. GLM4 ranked second, and Qianwen came in last. That said, Qianwen actually does better in Chinese language scenario, so it still has its strengths. Let's give up our mic back to Yu Yaogao.
Thank you, Ziqi. Finally, our presentation comes to a conclusion. To wrap things up, Logify has made big strides in turning natural language into clear logic diagrams. By using advanced large language models like Gamma and Qianwen with tools like Mermaid CLI, it cuts down manual work and makes complex logic easy to visualize, even for non-technical users. With an accuracy rate of 89% for flowcharts, it is already showing strong real-world potential in fields like education, software, and business. Looking ahead, we plan to boost performance with fine-tuning, RAG, and even AR/VR features aiming to make logic diagramming smarter, more collaborative, and easier for everyone. Thank you all for listening. Here is our reference list.